Hello and welcome to one of the CLIPC guidance videos. By means of our use cases, we aim to demonstrate which kind of analyses you can perform using the various CLIPC tools. This use case deals with the assessment of climate change impacts on winter tourism, for which the CLIPC platform is used to model the impacts. For this case, imagine the following scenario. The European Commission aims to initiate a funding program for regions in which climate change negatively affects winter tourism. The question is, how can those regions be identified? Our use case shows how the affected regions can be identified by considering two aspects: the climatic conditions and the dependency on winter tourism. For a basic analytical approach, we need to conduct two main steps. First, it is necessary to identify areas in which the climatic conditions for winter tourism will decrease in the future. Second, the areas dependent on winter tourism need to be identified. We can start by accessing the Combine tool and select the theme Temperature, the effect Ice Days, and the dataset KNMI Multi-Model Historical on the left, this one here. Next, we select the time period 1971 to 2000. On the right, we select the same theme and indicator, but choose the dataset KNMI Multi-Model RCP 8.5, this one, and select the time period 2071 to 2100. Both datasets receive equal weight since both use the same scale of measurement. Therefore, we don't need to choose a normalization method. As we want to calculate the change of ice days over time, we choose Subtract, name our output Shift of Ice Days, and click Execute. The result of the process represents the decrease of ice days throughout Europe, which is saved for our further analysis. Our assumption for this analytical step is that a decline of ice days indicates deteriorating conditions for winter tourism. To move to the second step, we can now combine our findings of the first step with data on skiing tourism. This can be done by means of the indicator Ski Lift Length, which can be found under the theme Settlements. We load this indicator into the Combine tool. The idea is that the higher the combined length of ski lifts within one cell, the higher the dependency of that region on winter tourism. As the other indicator, we will select Shift of Ice Days, the one we just computed before. As we want both indicators to be of equal importance, we use equal weight for each of the selected indicators. However, as the indicators have different scales of measurement, we have to select a normalization method. For the normalization method, we choose Min-Max to transform all values to a scale ranging from 0 to 1. Lastly, we will select the processing operator Add, assign the output name Result, and then click Execute. As a result, we can see which areas are likely to be particularly affected by climate change in terms of adverse effects on skiing tourism. Going back to the scenario of our use case, the identified areas offer a first idea of which areas might be in need of considerably more funding than less affected areas. It is important to note that this was a quick analysis, and a more in-depth approach would be necessary to obtain more meaningful results. If you want to learn more about what you can do with the CLIPC tools, please check out the help functions or have a look at our other guidance videos.